Welcome to Mrs. E's Chemistry. In this video, we will learn about 4.4, which is predicting the products of a few different chemical reactions. Let's start with single replacement reactions. If you remember from when we learned how to classify the different chemical reactions, single replacement reactions have one single element and a chemical compound, and then on the product side, we have a different element that is single and by itself and a different chemical compound. So we're going to learn how to predict what the products are given the reactants for a single replacement reaction. The way calcium is written here, it is neutral because it is by itself. It's in its elemental form. It is not an ion, nor is it in an ionic compound. But when it does make a charge in an ionic compound, calcium makes a 2+ charge. In lithium fluoride, lithium has a +1 charge and fluorine a -1. We can see that calcium would make a compound with fluorine because two positives would not make a compound. Calcium and fluorine need to make a neutral compound with each other. Calcium has a 2+ charge, fluorine a -1, therefore we need two fluorines in order to make a neutral compound with calcium. Then we have lithium by itself. We always need to double check whenever we have an element by itself to see if it is diatomic or not. If you go to your periodic table and look on the back, here's our diatomic elements. It's roughly in the middle. We can see that these 7 elements are diatomic. That means when they are by themselves, they exist as two atoms joined together in a chemical bond. Lithium is not one of these elements, so lithium is not diatomic, and therefore lithium can exist as one single element the way it's written here. Now that we have our chemical compounds with the correct subscripts, now we can balance it because we did not just spontaneously create an extra fluorine atom. Instead, I'll do this with a different color. Instead, calcium reacted with lithium fluoride in a ratio of 1 to 2, 2 lithium fluorides for every 1 calcium. And that means then we ended up with 2 lithiums on the product side. Now everything is balanced. Pause and see if you can do the next 2 by yourself before moving on to see the answers. Potassium makes a 1+ charge, strontium a 2+, chlorine a -1. Therefore, potassium and chlorine form a compound and strontium is by itself. Strontium is not diatomic, so we leave it the way it is written. And potassium is a +1, chlorine -1. Therefore, potassium chloride is a neutral compound the way it is written right there. In order to balance it, we need to put a coefficient 2 here so that now we have 2 chlorines on both sides because of this subscript. And then that means we need to put a 2 over here. So now the second one is balanced. Chlorine makes a -1 charge when it makes an ionic compound, sodium a +1, and bromine a -1. Therefore, we can see that sodium and chlorine will form a compound. Sodium is a +1, chlorine is a -1, so we just need one of each in order to make a neutral compound. Don't worry about the fact that we originally have 2 chlorines. We'll take care of that when we balance the chemical reaction at the end. First, we need to create our correct subscripts. And then we just have bromine left by itself. Bromine is on the diatomic list, therefore bromine doesn't exist as one single element by itself. It always exists as a pair by itself. Again, don't worry about the fact that it looks like we just spontaneously created an extra bromine. We'll take care of that once we balance it. Speaking of balancing, let's go ahead and balance this chemical reaction now. We have 2 chlorines on the left side, so let's go ahead and put a 2 coefficient on the right-hand side for sodium chloride, giving us 2 chlorines on the right-hand side. This also gives us 2 sodiums, so let's go ahead and put a 2 on this side so that now we have 2 sodiums on each side, 2 chlorines on each side, and 2 bromines on each side. And here are all of the answers. Now let's learn how to predict the products for double replacement reactions. This is where we have 2 chemical compounds reacting together, and you're going to take one element from each of the chemical compounds and pair it together. So let's start by writing out the charges. Sodium is a +1, nitrate, the NO3, is a -1. Remember, you need to look on the back of your periodic table for those polyatomic ions and be very familiar with them so that you recognize that nitrate is all one unit, NO3 together with a 1- charge. Potassium is a +1, chlorine is a -1. Therefore, we're going to take the positive sodium with the negative chlorine and write NaCl. +1, -1, this is neutral the way it's written. Now we're going to take our positive potassium and our negative nitrate to form KNO3. Potassium is +1 and nitrate is -1, so this is also neutral the way it's written, just one of each needed. This chemical reaction is balanced the way it is written. Pause to see if you can do the next two on your own before moving on to see the answers. Strontium is a +2. ClO4 is the polyatomic ion perchlorate, and it has a -1 charge. NH4 is the polyatomic ion ammonium with a +1 charge, and SO4 is the polyatomic ion with a -2. This is why it's very important to be familiar with your polyatomic ions. Strontium is going to make a compound with the negative sulfate. +2, -2, this is neutral the way it's written. The positive ammonium with the negative perchlorate make a compound like this, ammonium perchlorate. Now, all of the subscripts in our products here are correct because everything is neutral. Now we're going to balance it. We have 2 perchlorates and 2 ammoniums on the left-hand side. So if we put a coefficient 2 on the right-hand side, now we have 2 ammoniums and 2 perchlorates on both sides. We still always just had 1 strontium on each side and 1 sulfate on each side. So this second reaction is also now balanced. Potassium is a +1. Carbonate, CO3, is a 2-. Barium is a 2+, phosphate is a 3-. Potassium is going to form a compound with phosphate. Potassium has a 1+ charge, and let's write this up here, and phosphate a 3-. Therefore, we need 3 potassiums in order to make a neutral compound between potassium and phosphate. Don't worry about the fact that we originally only had 2 potassiums here and 2 phosphates here. We will take care of that later when we're balancing. Right now, we're trying to make neutral compounds as the products. Okay, so our second product is barium and carbonate. Barium has a 2+ charge and carbonate has a 2- charge. Therefore, we just need 1 of each. 1 barium and 1 carbonate. Again, don't worry about the fact that we originally had 3 bariums. We'll take care of that later when we balance this whole chemical reaction. Speaking of balancing, let's go ahead and balance. Look at the fact that we have 3 bariums on the left-hand side. Let's go ahead and put a 3 coefficient here so that we produced 3 barium carbonates, balancing the bariums. This gives us 3 carbonates as well on the right-hand side. So now let's go back over to the left-hand side and see that we only have 1 carbonate as written. Therefore, let's put a 3 coefficient out in front to make a 3 carbonates with the potassium carbonate here. This gives us 6 potassiums. So if we put a 2 right here, therefore we've got 6 potassiums on this side as well. This 2 gave us 2 whole phosphates, which we already had 2 phosphates on the left-hand side with this subscript 2. Oops. There. Now everything on this page is balanced. Acid-base reactions are actually very similar to double replacement reactions. If you remember, an acid is a compound with the hydrogen in front, so HCl, HF, and H2SO4 are all acids. Bases have hydroxide at the end of the compound, sodium hydroxide, calcium hydroxide, and potassium hydroxide. These are all bases. So when you have an acid and a base and they neutralize each other, they produce always a salt and water. If you remember, a salt is not just sodium chloride. Any ionic compound is a salt. All right, so let's look at this. We have a +1 and a -1. Sodium is a +1 and hydroxide is OH. It is the polyatomic ion OH with a 1- charge, and it's called hydroxide. Sodium and chlorine make sodium chloride. That is the salt. It also happens to be table salt, coincidentally. And then we have our positive hydrogen and our negative hydroxide making HOH, which of course is water. You can write it either way, HOH or H2O. This chemical reaction is actually balanced the way it is written. Let's pause to see if you can write out the products of the next two. Hydrogen +1, fluorine -1, calcium 2 plus, hydroxide -1. Calcium is going to make a compound with fluorine. We need a neutral compound, so we need 2 fluorines to make a neutral compound with the calcium, which has a 2+ charge. Calcium fluoride is the salt in this acid-base reaction. Then we know we're also going to produce the water, which comes from the hydrogen and the OH. Don't worry about the fact that we have 2 hydroxides here. We'll take care of that when we balance this chemical reaction. Speaking of balancing, we have 2 fluorines on the right-hand side, so let's put a 2 out in front over here, and then that means we need 2 water molecules. So hydrofluoric acid, the HF, reacted in a 2-to-1 ratio with calcium hydroxide, and it produced calcium fluoride, 1 molecule of calcium fluoride, and 2 water molecules. We have positive hydrogen. Sulfate is a 2-, potassium is a +1, and hydroxide is -1. The potassium and the sulfate create the salt. We needed 2 potassiums because potassium is a +1 charge, sulfate is a -2 charge. So we need 2 potassiums to make a neutral compound between potassium and sulfate. Then we produce water because acid-base reactions always produce salt and a water. The water came from the hydrogen and the OH. Don't worry about the fact that you had 2 hydrogens here. We worry about that later, or resolve that later when we're balancing the chemical reaction. So we need a 2 coefficient here and a 2 coefficient here to balance it. Pause to double check that all of the atoms are balanced. This, by far, is the easiest to predict, the combustion reactions, because combustion reactions always produce carbon dioxide and water. So without even looking at the chemical reactants, we can write CO2 and water. CO2 and H2O. Then we can balance it. In order to balance, I would pause and work that out on your own for good practice before seeing the answers. We have a 2 here and a 2 here. C2H6 has, we're going to need, if we start out by putting a 3 here and then a 2 here, we can see that gives us a total of 4 oxygens from the carbon dioxide and 3 more oxygens from water. That gives us a total of 7 oxygens on the right-hand side, but we can only have an even number of oxygens on the left-hand side. So this tells us we need to double all of the coefficients that we currently have. The 2 becomes a 4, the 3 becomes a 6, and now we can make this a 7. Pause to convince yourself that that is correct. For this last problem here, it says write the reaction for C3H8 burning. That means combusting. So this is a combustion reaction. We have C3H8, that's the hydrocarbon. A hydrocarbon is any molecule with just carbon and hydrogen. Sometimes it can also have oxygen in it, in the compound itself. Remember that combustion reactions must always burn or combust in the presence of oxygen. This is why a fire blanket works, because if you smother the fire and don't give it any more oxygen, it will go out. So therefore, combustion reactions must always have oxygen as a reactant. Combustion reactions always produce carbon dioxide and water, and then you can balance it. Let's put a 3 here so that our carbons are balanced. If we put a 4 here, then our oxygen is balanced, or our hydrogen is balanced. This gives us 3 times 2, that is 6 oxygen atoms from carbon dioxide plus 4 more from the water molecules. So therefore we have 10 water molecules on the, or oxygen atoms on the right-hand side. Therefore let's put a coefficient 5 on the oxygen on the left-hand side.